First, describe what inverse mean. So, for example, we have 3. What is the inverse of 3? 1/3. If we have x, what is the inverse of it? 1 over x. How did we get this? Because the fraction form of 3 is 3 over 1. When we say inverse, it can be its reciprocal. So, x over 1, its inverse is 1 over x. Okay? That's what we mean by inverse. Now, let's inverse variation. We have the symbol y is equal to k over x. How did we get this? From, this is inverse variation and this is direct variation. From direct variation, we have y is equal to kx. And for inverse variation, it will be inversely proportional to x. So meaning we are taking that variable x and get its reciprocal. So what is the reciprocal of x? 1 over x. So we multiply this with k. So that would be y is equal to k over x. That's how we get inverse variation formula, where again, k represents the constant of variation. Do not forget the statements that will lead you to an inverse variation problem. Inverse varies inversely as, varies inversely to, and inversely proportional to. X is inversely proportional to y. X is inversely proportional to y. Next given, the force needed to break a board varies inversely with the length of the board. So we have F varies inversely with the length. That's our number 2. And for number 3, the time required to empty a tank varies inversely with the rate. With rate. Okay? That's how we translate equations from mathematical statements. Given a table, Nathan wants to have an extension of his house. He clearly knows the number of days to finish the work depends on the number of workers. Some possible number of days and number of workers are as follows in a tabular form. Observe the given entries. In the first row, we have the number of workers, n, 2, 4, 6, 8, and 16. Observe they are all increasing numbers. In the second row, we have the number of days, taken 24, 12, 8, 6, and 3. Observe they are quantities that are decreasing. As you observe that they are opposite, one is increasing and the other is decreasing, this is a table that represents inverse variation. Now, let us take note if it's really an inverse variation. We need to take the product of each pair, N and D. So, let's take 2 times 24 is 48. 4 times 12, 48. 6 times 8 and 8 times 6 is also 48. 16 times 3 is 48. Now, what can you say about the product of all of the entries that we have? It is 48. So, if 48 is a constant value of the product of our tabular form, then we can say that our constant of variation k is now 48. And our equation for this will be days is inversely proportional with number of workers. As we change the value of k, our new equation for this would be d is equal to 48 over n. This is the equation of our given table. For our next example, y is inversely proportional to x given the table. Observe values of x increasing, values of y decreasing. Then, let's find the constant of variation. K is equal to the product of x and y. So, what is 2 times 60? Your answer is 120. So, the constant of variation is 120. Let's check from the other entries. 4 times 30, 120. 6 times 20, 120. Then we can conclude that our constant of variation is 120. This time we change the equation of this given table. At first, we have y is equal to k over x. Finding the value of the constant will make our equation equal to y is equal to 120 over x. From the table of values. How are we going to write the mathematical statement for this graph? First thing, take note of the variables that will represent the y-axis and the x-axis. Let us focus first on the first graph. The graph, by the way, the graph of an inverse variation is called hyperbola. Hyperbola. Okay, so let's have the observation. The values of x values, horizontal numbers, are increasing. Observe the values for the y-axis or the time. It is also increasing. Now, let us take the mathematical statement. So, time is in the y-axis. So, t is equal to k over the x values, which is speed. So, this is now our mathematical statement. T is equal to k over s. And then to find the value of k given that graph, let's take values for y and x. So, let's take, if x is 4, what is your y? So, from that point, what are the coordinates of this? We have 4 and y is 30. Now, let's solve for k. We have 4 times 30. K now is 120. Now, we'll change the equation. T is equal to 120 over S. This is the equation represented by the graph. Let's check one more if it's really K is 120. When X is 2, what is your Y? Observe carefully. Y is 60. When we solve for K, 2 times 60 is equal to 120. Therefore, the graph really is a graph of inverse variation with a constant of 120. Let's take What is in the y-axis? It is the length. Is varies inversely with the one in the x-axis, that is w. Now let's find for the value of k by getting a point from the graph, which is a hyperbola. So that we have 6. If x is 6, y is 2. We solve for the constant of variation, 6 or x times y. As we substitute, 6 times 2, k is equal to 12. Let's take one more to make sure. If x is, let's take x is 6. I'm sorry, we're done with that. Let's take x is 3. If x is 3, our y is 4. K is equals to xy. Then k is equal to 3 times 4. Answer is 12. Then really, the constant of variation is 12. Now we can change the equation with the length is equal to 12 over w. This will be the equation of our graph of the inverse variation.